So the next question is on syllogisms. So try it and give me the answer. Try this. This question is on syllogisms. So you have to find out which of the, there are no directions given. So I'm going to assume that the directions is you have to find out which of the conclusions definitely follow. The question was posted by Sony. So what is given here? All rocks are mountains. All rocks are mountains and no stone. So no stone is a mountain, and it is given all stones are cement. Okay, first conclusion. Some mountains which are rocks is also part of cement. So basically these mountains, right, whichever mountains are there here, these mountains are part of cement. Not necessarily true, right? See, even though they have said here some mountains which are rocks, that just means they are referring to this set of mountains. Okay, they are not talking about rocks, they are just referring to this set of mountains. These mountains are cement. It needn't be true, right? These mountains can be cement, cannot be cement, we don't know. So this conclusion is not a definite conclusion, does not follow. No cement is rock. Again, no cement is rock. There can be some intersection between cement and rocks. Again, we are not sure of the same. So the second conclusion also does not follow. So the correct answer here will be neither follows. So the first conclusion basically says some mountains are cement. Here no cement is rock. Both don't follow. So the answer will be neither follows. The next question is posted by Kala. Again a question on syllogisms. So again here directions are not given. So let's assume that the question is asking us about which of the options follow or which of the conclusions follow. So try this and give me the answer. So let's draw the basic diagram for this given information. What is given? All squares are cones. All squares are cones. Some squares are angles. Let this be squares, and some squares are angles. Some angles are circles. So some angles are circles and some triangles are not angles. So there is a set called as triangles, and between the set angle and triangle, some triangles, right, this set of triangles are not angles. They are disjoint. This part of the set is disjoint. Okay, sorry, some no, not like that. Yeah, some triangles are not angles. Okay, then now let us look at the options that is given. First option says some squares not being triangles is not a possibility. So some squares are not triangles. Let us see that some squares are not triangles. Is that a possibility? Some squares are here, triangles are here, right? Some squares are not triangles. That's definitely a possibility, correct? Some squares, might be these squares are not triangles, right? What is given here? The first option says some squares not being triangles is not possible at all, right? So this can never happen, right? That's what they are saying. Some squares are not triangles, cannot happen at all. But some squares are not triangles, can happen, correct? Some squares, see, this first option, how you interpret is some squares are not triangles, correct? So this here it is saying some squares are not triangles is not a possibility. Okay, now just check if some squares are not triangles is a possibility. Can this happen? Can this happen? Yes, might be these set of squares are not triangles, right? This can happen. This is a valid possibility. It is not violating any other condition. So I cannot say for sure that this can never happen. So this option does not follow. All triangles can be cones. All triangles can be cones. Yes, this full set triangle can come under the set cone. Can be means it shows again a possibility. Yes, that is possible, correct? It is a possibility. So this follows. At least some cones are angles. Yes, definitely some cones are angles. These cones are definitely angles. At least some. All this refer to some. Some cones are angles. Definite. That's a definite conclusion. Some cones can be circles. Yes, some cones can be circles. See, can be means again that's a possibility. There can be some intersection between cones and circles. So this also follows. All cones can be squares. Yes, all cones can be squares. See, what I know is that all squares are cones, but the set cones and squares, they can also be just one set. The same set can be cone and the same set can be square, right? So all cones can be squares too. So the option 5 also follows. So what is the correct answer here? Except option 1, all the other options follow, right? So 2, 3, 4 and 5, all of these will follow. See, they are not saying, some of you are giving me the answer as 2, 3, 4 and not 5. All cones can be square. So all cones being square is a possibility, correct? The square set and the cone set, they can be the same set. That is possible. So the correct answer here will be 2, 3, 4 and 5 follow. I hope it's clear. So this was posted by Kala. Kala, I hope it's clear for you now.